There have been some significant improvements to tool axis definition for PowerMILL 2013. A new tool axis mode option has been added to the tool axis definition form. This gives big benefits, including the ability to set the lead and lean angle of a raster toolpath, for example, relative to the toolpath's contact normal. So this effectively gives us multi-surface, surface normal raster finishing. Also, for other projection type toolpaths, the tool axis can now be defined relative to the toolpath's final position on the part, instead of in previous versions where the tool axis was defined relative to the preview frame of the pre-projected toolpath. Let's take a look at a few examples of this new tool axis mode option. So let's switch off two of the parts and just leave the part on the screen that we want to create a toolpath on. So in this example we want to create a toolpath to machine this highlighted groove that we can see running vertically down the side of our boss. So to do that, to create that toolpath, we're going to use plane projection machining, and if I draw the preview plane, you can see that in the correct position there. So let's go ahead now and create the toolpath using the functionality available to us in PowerMILL 2012 R2. So this is the previous functionality, how we would create the toolpath. So let's just switch off the shading for the tool. And I'm going to draw the tool axis that I defined for this operation, and that is from a line, and you can see the line drawn in position there. I'll just rotate that round a bit. So we've used plane projection, and this is our tool axis, so we would expect the tool axis center always to go through this line. But in reality, because of the way plane projection worked, or any projection method worked, the tool axis didn't go through the tool axis from line as the user would expect. So if we simulate from start and apply, you can see if we look from the side that the tool axis is not going through the line, which happens to be where our work plane origin is. And in this case it gives a very undesirable result. Okay, where the shank is hitting the part before the tool, and our toolpath is very fragmented. So even though we've specified the line that we want the tool axis to go through, the toolpath doesn't actually go through that line. And the reason for that is because in PowerMILL 2012 R2 and previous versions of PowerMILL, the tool axis was applied on the preview frame. So this is the white frame with the arrows on that I drawn on the screen before I created the toolpath. So let's just clone that toolpath now and use the new tool axis mode option to give us the correct result with the tool axis exactly as we want it. And to do that we use what's called toolpath mode. So the tool axis will be defined on the toolpath at its finished finished position after it has been projected. So you can see now we have a much neater toolpath that looks correct. And if I simulate from the start this time and view from the side, just draw my tool. You can see now that the toolpath is exactly where we want it to be. So let's now take a look at a second example using a different type of toolpath. So this time we have a cavity mould, and we're going to be using surface projection to machine this. So here you can see my projection surface, which is underneath, sitting underneath the actual cavity itself. And again, first of all, we'll create the toolpath using the previous functionality in PowerMILL 2012. So all the settings are correct. If I draw the preview frame, so there we can see the preview frame for the surface projection, and as I've just explained in the previous toolpath, the tool axis is applied to this preview frame and then projected onto the part. So the tool axis is correct before projection, but after projection the tool axis then is incorrect. In this case we still get a toolpath that is acceptable, and if I attach the tool to the start and view from the side again, and simulate that, it gives us a reasonable result that we could actually use. However, it still doesn't go through the tool axis we defined, which you can see here with our point. So if we look at the tool axis form, I've got from a point 50 mm above the top of the part, but our tool isn't actually going through that point, so it's not giving us the result that we would expect and the result that we've actually defined on the tool axis form. So let's go back to the settings for this toolpath. And once again we're going to clone this, and we're going to use the new tool axis mode option to specify the tool axis relative to the toolpath's final position. So now if we simulate from start, you can see that at all times throughout the whole of the toolpath, if we animate it, the tool is going exactly through the point we specified. Let's take a look at one final example, and this time we're going to create a raster toolpath over this speaker casing. Now raster is a projection type toolpath and uses a preview frame like all the other projection toolpaths. So if we go to the settings for this toolpath, and we can draw the preview frame as before, you can see that there, and likewise the tool axis is defined to this preview plane. So in this case I've used a tool axis of lead and lean 0, 0. Now typically users think of this as normal to the surface, But in the case of a raster toolpath, this is actually normal to the preview plane of the raster. So lead and lean 0, 0 in this case will give exactly the same result as a vertical toolpath. So if I attach the tool to the toolpath and simulate it, you can see when we look from the side, the toolpath is vertical at all times, and that's because the preview plane was flat in the XY plane, and that's just projected straight down in Z. But now, with the ability of toolpath mode, we can convert this into a surface normal lead and lean toolpath. And to do that, we simply go to our mode option, and this time instead of toolpath we choose contact normal. Now the options in here will change according to the type of toolpath. As you saw in the previous examples where we had surface projection and line projection, we didn't have a contact normal option. We had what's called a toolpath option. So these will change depending on the strategy. So if we change that to contact normal lead and lean and calculate the toolpath, this gives us a very special result, and it's a huge improvement for PowerMILL 2013, because effectively what we have now is multiple surface perpendicular machining or surface normal machining relative to the contact normal. So if we simulate from start now, you can see at all times the tool is staying normal to that surface. Let me just jump ahead to somewhere in the center rather than where it rolls over the end, and look from the side again. So here we can see it going down, up and over the part, all times staying normal to the surface. As well as that, we can, if we wanted to get the tool away from the tool tip where it doesn't cut very well, we could go to our tool axis and apply a lead on that of say 10 degrees. So now this will be a lead which is relative to the surface normal. Again, if we attach the tool somewhere in the center, so now you can see the tool is tilted over at 10 degrees relative to the surface normal.